Okay. Welcome, Dr. Tyson, to the very first interview I'm doing this year to publicize the upcoming conference of the
Well, please
Committee
call
for
me Neil. Thank
Skeptical
you.
Inquiry.
Thank you for that invitation.
All right. So for people who don't know, the conference is known as CSICon conference, and it's going to take place in Las Vegas from October 20th to the 23rd. And you are our featured speaker this year, and I'm very excited to be able to talk to you today. Thanks so much for agreeing to do this.
Thanks for having me.
In case there are any viewers here who don't know who you are, I don't know how that can be, but I'm going to read your bio.
It can happen.
2022 page. I told several friends of mine, I'm getting to interview Neil deGrasse. Who's that? It's like, oh, I need
Okay, that's
different
fine.
set of friends.
In fact, I was once the clue on a Jeopardy question.
What was the answer?
It was something really easy, I would have thought. This person blamed for demoting Pluto or something is director of New York's Hayden Planetarium. And there were three people, they might have been in their 20s, and they had enough geek street cred.
You thought they would get that.
If you're on Jeopardy, you got some geek street cred.
Oh, yeah.
And all three of them blanked. And so it made a funny sort of, what was it? Where I forgot.
Who did they put down? They had a guess, probably something.
But did they? No, they didn't even guess. They just, all three of them was like blank.
They didn't even hit the button to say something.
Yeah, crickets chirping, right? And there wasn't even a button. Nobody hit the button. And so I forgot whether I posted it on Instagram or TikTok, but we replay that, and I say, I'm right here. Jumping up and down.
I thought about bringing up Pluto, and no. I actually have a shirt that says, when I was your age, Pluto was a planet. But
yeah, there you go.
So, all right, Neil deGrasse Tyson is an astrophysicist, a planetary scientist, a science communicator, a former advisor to NASA, an author of 15 books. Is that still current, 15?
Well, just the planetary scientist part, I was never that. Somebody put that in my wiki page. And so that's how I know when someone is digging up my bio from the wiki page.
Ooh, I'm going to tell them about that.
Rather than from my actual website. That's how I know.
Ooh, actually, I have a question about Wikipedia later. That's interesting. Okay. The director.
And I tried to edit. They won't let me edit it.
Oh, no. Yeah. I'm on a team. We'll talk about that later. That edits Wikipedia. And yeah, there are rules. You can't edit your own page.
Yeah. So maybe you could fix it. Thank you.
Neil's a director of the Hayden Planetarium in New York City, which was a childhood haunt of mine, a research associate of the Department of Astrophysics at the American Museum of Natural History right next door. Also love that. The host and narrator of the previous 2 seasons of the Emmy-winning Cosmos series, A Space-Time Odyssey and Possible Worlds. The host of StarTalk podcast and television series. And lastly, but not leastly, a fellow of CSI, which is what this interview is for, the Committee for Skeptical Inquiry. Welcome again, Dr. Tyson.
Thank you. And please call me Neil. Yeah.
Okay, so my first question was going to be about the planetary scientist thing. That's interesting. So you jumped right in there, and that's...
Well, I mean, I have published a paper that is based in the solar system, and it was on the planet Uranus. Okay. And so, but that's not my main bread and butter as a professional scientist. It's mostly stars and galaxies, not planets. So I don't know how that landed in there. For a while, it had cosmologists in there too, which I'm not. And I managed to edit that out of the page. And then when I went to the second edit,
I'm going to edit this out that you said that, because you're not supposed to do that. I don't want the Wiki police to track you down, because it's easy to find you.
Yeah, so, but if we want it to be accurate, we should, to prevent the person who knows what it should be from making it accurate in favor of those who don't know what it is, leaving it inaccurate didn't really make sense to me. But
well, see, so Wikipedia needs citations. Even if a famous person says, this is not true, please change it, it's not good enough unless it's in some published source. But this will be in a published source. So someone can take this, someone from my team, hopefully, and make the corrections.
Excellent. Well, thank you.
That's excellent. So the question I had, and I'll leave off the planetary scientist part, was what is the difference between astrophysicist and astronomer? And since you mentioned cosmologist, I don't even know what that was. So how would you say, what are those 3 differences there?
So astronomy is sort of an old-fashioned term for this. Astronomy is anyone who concerns themselves with what happens. I guess we can include inside our atmosphere, but beyond Earth's atmosphere out to the edges of the universe. Beginning in 1895, a journal arose which exploited the fact that we applied significant laws of physics to understanding what's going on in the astronomical universe. And so the term astrophysics was born in a significant way with the birth of the Astrophysical Journal. And it was the juxtaposition of the spectral analysis of light from stars and learning what those molecules are doing in those, and atoms are doing in those stars, upon the analysis provided to us by physicists and by chemists. So today, everyone who studies the universe is an astrophysicist. And now when you divide that up, you get the people who specialize in the origin and evolution of the universe. They would be cosmologists, not to be confused with cosmetologists. Okay. They're the people who worry about the
origins.
Well, we all worry about origins, so that crosscuts. But they're the people who think about solar system objects. So these would be planetary scientists, and typically the planetary astrophysicists. They concern themselves with not only planets but moons and comets and asteroids, this sort of thing. And then what else might you have? And a subset of them care about exoplanets, the planets orbiting around other stars. And so, but astrophysics would be the catch basin for it all.
Okay, so I actually wrote the Wikipedia article for Alan Hale, Hale-Bopp comet, and he and another person who's listed on Wikipedia as an amateur astronomer, that's
Yes.
Bopp. So they wouldn't be an amateur astrophysicist, right? You would still use the name astronomer for somebody who's an amateur looking at it.
And by the way, I think amateur astronomy is the only place in the world, is the only sentence that exists where the word amateur is a praiseworthy word in that sentence. If you say, I'm an amateur astronomer, it's like, oh, tell me about your telescope and the night sky. And they're experts on everything that happens in the night sky. Whereas an amateur neurosurgeon, an amateur attorney, there's not much else you're going to stick amateur in front of and then have it mean something less.
Amateur airline pilot.
Exactly. So amateur astronomer is actually a badge that is worn proudly. I was an amateur astronomer coming up as a kid. I had my backyard telescope, and I took it out in the street, and people would line up, and I'd show them the craters and valleys and hills on the moon and the rings of Saturn and the moons of Jupiter. And we all do that. And so I still have a deep amateur astronomy within me. But right, astrophysicist is really the profession, and you wouldn't be an amateur astrophysicist.
Right. Cool. Okay, so you're here because of the upcoming.
Well, now we got that out of the way.
Yeah. So let's talk a little bit about the CSICon. Well, actually, I'm going to put that a little bit ahead because the timing of this interview is amazing, and I'd be remiss if we didn't talk about the just released images from the James Webb Space Telescope just yesterday. So yeah, I'm sure you've pored over those. I've seen them popping up all over my social media. Is the telescope living up to its expectations thus far?
From what I can see, it's exceeding our expectations, only because, you know, when you launch something that complicated and it folds up into the fairing of the launch vehicle, and then it has to unfurl like the petals of a flower, and it's sitting 1,000,000 miles from Earth in the opposite direction of the sun, all that has to work. So at some level, your expectations get softened because you want to allow something to mess up, and then you're still okay with it. And there was a micrometeoroid that struck one of the mirrors, but there are many mirrors.
I heard that.
And you'd be surprised how effective mirrors can be, even if there's a blemish in one part versus another. So it is doing exactly what we had hoped it would do. So, and our expectations having been tempered by the complexity of the mission, I can say it's doing what we had hoped it would do and is exceeding our expectations. I'll say both of those sentences.
So what amazing revelations are you looking forward to in the coming days, months?
I have a cop-out answer for you. So the standard answer is, I wanted to see all the stuff we expected to see. It is tuned to observe galaxies being born in the early universe. No previous telescope was tuned to be able to do that, not only in the part of the spectrum necessary to do the measurements, but also in the sensitivity to light to detect the very dim things. They're dim because they're very far away, not because if you were standing up next to them that they'd be dim at all. So that's one of its tasks is to discover what galaxies are doing while they're being born. That's a gap in our prior knowledge for all telescopes. Because it is sensitive to infrared, it turns out, infrared is an exquisite band of light to penetrate gas clouds nearby where star systems are being born. And so it's excellent for studying stellar nurseries as well. And in the spate of 5 images that were shared with the public, it was an attempt to show the public, look at what we can do. We can go far, we can go near, we can, it's like the baseball player, he can field to his left and to his right, and he can do this and he can do that. And so here we are listing the qualifications for its next job, or for anyone else that wants to propose to observe with it. One of the images was not an image, it was a spectrum.
The exoplanet.
Which is how we get most of our data from the universe, is spectra. The beautiful images, the public likes it, but that's more sort of window dressing on the engines that we operate to learn what the universe is doing. So, because with the spectrum, you can learn, for example, how hot the thing is, how fast it's rotating, what it's made of, how fast it's moving towards you or away from you. Is the light reflected or is it absorbed? What the chemical composition is. All of this happens in a spectrum. Whereas a picture, you can say, "Oh, that's beautiful. There's something near it on the left," So, but we recognize the public needs and wants pictures, and so do we, the professional community. It gives us it boosts our enthusiasm to continue.
Sure. So what about the exoplanet atmosphere?
Oh yeah. So what that showed was a measurement of gases in the atmosphere of an exoplanet passing in front of its host star.
And that's a first, right?
So it's the first to be able to measure it at that scale. All right. This has been a cottage industry for several years. People knew this would be very important if we finally perfected this technique using the best telescopes available. And there's some early attempts at this, but this blows it out of the water. And speaking of water, one of the measurements was the water molecule thriving in the atmosphere of an exoplanet orbiting another star. Water is, as we know, is fundamental to life as we know it. And so the fact that there's water in the atmosphere itself doesn't say there's life, but if we think it's a prerequisite, then it means we should keep looking.
And is this planet an Earth-size type planet?
Yeah, we were targeting Earth-sized planets around sun-like stars. It's a little more massive than the Earth, but it's in the same category as Earth. Yeah.
Wow, amazing.
So and this is just a taste of what is to come. And I agree. I forgot who said this. Someone from NASA or one of the project scientists said that we will remember this date because everything that happened before it will be supplanted by all that happens after it. Oh. So our memory of cool discoveries in astrophysics won't go before this date, because nothing before this date will be as good as what happens after.
Fantastic. So, all right, forgive me for this in advance. I came across this post yesterday on the page of a Facebook follower of mine, Dave Rusnick, about NASA's plans for a new instrument. And I want to know if you've heard about this. The James Webb Telescope, this is the post. The James Webb Telescope has found a massive amount of space junk and stardust through the universe. To mitigate this, NASA is developing a massive intergalactic vacuum cleaner type device to suction debris from the universe. It's called the Neil deGrasse Dyson.
Yeah, so I think the world needs trolls like that. So, so that
there you go, Dave. You're
yeah, no, I think
troll.
that the trolling is a reminder that not everyone is enthusiastic in the same way you are about what's going on out there. And
I think he was being facetious. I think
that's fine, facetious or otherwise. I think the the as an educator, I like being reminded that such people are out there. Not that I like being reminded. It is helpful to me to to notice that not everyone has equal enthusiasm, and different people have different senses of humor about things. So that when I encounter the public, I can gauge what I say and how I say it,
read
what
the
words
room.
I use, the tone I use,
Mhm.
so I can be most effective with whatever audience I happen to be in front of. And I don't lead the delusion that everybody is just as enthusiastic about it as I am, because that would be delusional. And I don't.
I'm seeing most people being enthusiastic. Well, again, I'm looking at science channels and things like that, and people following those. So I guess that's a subset and sort of
Yeah, well, that's a
bias.
pre-selected. You got to spill out a little.
Yeah, yeah.
Yeah.
So taking a piece of what was in there on a serious note about the stardust and junk through the universe. So the further you look, the more stuff is in the way to see what you're looking at. And you already mentioned that certain frequencies go better through those things, right?
Yes.
So that's been accounted for by the James Webb.
Oh yeah. Well. So first of all, sight lines. The universe is mostly empty, so sight lines go very far before they encounter things. And between galaxies, it's pretty empty. They're these sort of very low mass objects that are gaseous, but visible light passes right through them. But radio wave telescopes can pick them up. So yeah, the universe is full of stuff. A big part of the 20th century was inventorying the stuff in the universe so that we can know how to think about it, know how to pose the next generation questions about them, how to design the next generation telescopes in order to answer new questions posed by these new objects that occupy this portfolio. So I'll just give one quick example. While I was in graduate school, we had a catalog of peculiar objects in the night sky. Okay. The Atlas of Peculiar Galaxies is what it was. I forgot objects that were and so you look at them and say, this looks like it wants to be a galaxy, but it's really distorted. This is a sorry looking Did something happen? It was born? Was it and nobody knew. This is from the 1960s into the early 70s. And then computer models, once computing got good enough and fast enough, we realized, oh my gosh, this is a regular galaxy that is in the act of colliding with another galaxy that is disturbing and distorting its shape. And one of the leading scientists of the day, Gerard de Vaucouleurs, has noted that a wrecked Lexus is still a Lexus. It's not a different kind of car. All right.
Interesting analogy.
Yeah. I think he drove a Lexus, and this is what his. So that was an example of inventorying things, not knowing what it is, but we know they had something in common, and then figuring it out later. So now we're not thinking of a disturbed galaxy as being a peculiar object. It's just a galaxy. And one of the 5 images released by the NASA JWST team is called Stephan's Quintet.
Oh, I haven't
and it's
seen that.
5 galaxies in one field of view, 4 of which are interacting. And none of them look like a perfect 2-armed spiral galaxy, or they're clearly distorted in their shapes because the gravity across them, which specifically the change of gravity across them, which is called the tidal force, will reshape the part of the galaxy nearest the other galaxy more than it will the part of the galaxy that's farther away. And that creates a distortion.
Fascinating. So on regarding new discoveries and looking at things that we found but don't understand, will this telescope help solve the dark matter, dark energy mysteries? There are a few questions from my Facebook followers, specifically, how close are we discovering what dark matter is? What's the absolute latest on it? And I want to ask you something about this. On a previous StarTalk, quite a few years ago, you were reading viewer questions, I think. And one of them was about this. And you said something like, correct me if I'm wrong, they shouldn't have named them matter and energy because we don't even know the matter and energy. They should have named them Fred and Ethel. Do you remember that?
Yes.
And
Yes.
like, so what's your thoughts on that these days?
Still, dark matter and dark energy are two highly mysterious things in the universe. Mysterious in the sense that we can measure them, we can quantify them, but we have no idea what they are. By the way, that's not unusual. When we first put spectroscopes on stars, we saw all of these features within the spectrum. They look like lines in a photograph. So to this day, they're called lines, spectral lines. We didn't know what was causing them, but we knew they must be important. So we kept catalogs and classified them based on their spectral type. And later, only after quantum physics was advanced in the 1920s, we are in the centennial year, in the centennial decade of the discovery of quantum physics, by the way, and the development of quantum theory. Once that was understood, then we knew how these things happen in the spectrum of molecules and atoms. And so, but we had a marvelous data set going into it. So right now we're trying to get as much data as we can on dark matter, on dark energy. Dark energy, it really should be called dark gravity. It's 85% of all the gravity of the universe has no known origin. That would be a very precise naming of it. The fact that it's called dark matter implies that it's matter. Maybe it is some kind of exotic matter. I don't know. But that's not what we're observing. We're not observing matter, we're observing gravity, just to be clear. With dark energy, there's some mysterious pressure in the vacuum of space, forcing the universe to accelerate in its expansion, opposite the wishes of the collective gravitational force of the constituent galaxies. We can measure that. We do not know what's causing it. If you add up the dark matter and the dark energy, it's 95% of what is driving the universe.
That blows my mind.
And we are clueless about it. Everything we know and love, and in our books and everything, and we can and have lab tests and everything, is in the 5% that we know and love and understand. The biology, the chemistry, the physics, all the astrophysics lives within that 5% of our cosmic knowledge.
Is there some chance that both or either of those things aren't really separate items, but that there's something fundamental about the laws of physics that we don't quite understand, like when we went from Newtonian physics to Einstein's concept, and basically understanding the universe better? Is there a possibility that that's the case?
Yeah, of course. Oh yeah. I mean, anything's possible. Let me get back to your Fred and Ethel point. So dark energy, I don't know that it's energy. Who knows what it is? So they really should not have gotten those names, because it biases people's thoughts as they try to figure out what it is. And it leaves you with headlines, journalist headlines, that are just make no sense at all. They'll say, dark matter, new theory says we don't need dark matter at all. Okay. No, it's not how that works. Okay. Because they're trying to say that it's not, that somebody has an idea where whatever it is, it's not matter. So therefore it's overthrowing an understanding. No, we don't have an understanding. So there's nothing there to overthrow. All right. If you have a new way to explain the gravity, fine. Okay. Bring it on. All right. So in fact, there is something called modified Newtonian gravity. MOND is the acronym. And there's a whole team of people who are thinking it's not this mysterious thing that we don't know about, Ethel, whatever, that Newtonian gravity will do just fine if you make some adjustments to it.
Oh, okay. So that's
but the point is, I want to distinguish these from something like the ether. Ether was all the rage 130 years ago. Whole books were written on the ether. This is the mysterious medium through which light travels. We knew that sound requires a medium to vibrate for it to propagate. because it's vibrating the molecules. Light is a wave like sound, so it clearly needs a medium through which to travel. But we think space is empty. It's empty of everything you know, but there's this ether, and that's the thing that's vibrating. So people calculated the properties of the ether and all kinds, and what things would look like if there's a lot of ether versus a little bit of ether. And then the ether evaporated overnight, because we learned that light is not like sound. It is a self-propagating wave that does not vibrate a medium through which it moves. Point is, the difference between dark energy and the ether is that the ether was never measured. There was never a measurement of the ether. It was assumed to be there. Whereas dark energy, we have measurements of it. And dark matter, we can find the locations of dark matter, Ethel, in the universe, because we see its effects gravitationally on the surrounding matter. And so there you have it.
Absolutely fascinating. All right, so let's get to the topic that I have you here for, CSICon. So as I mentioned, you're going to be speaking at the conference this year. Your talk is scheduled for Thursday, October 20th at 8:15, and it's immediately following the opening reception. It is titled,
Las Vegas.
Say that?
In Las Vegas.
In Las Vegas at the Flamingo Hotel. It says right over my shoulder.
Mm-hmm.
It is titled The Cosmic Perspectives on Civilization, and I'm going to read how it's described. Bringing his cosmic perspective down to earth, Neil deGrasse Tyson shines new light on the crucial fault lines of our time: war, politics, religion, truth, beauty, gender, race, in a way that stimulates a deeper sense of unity for us all. All of that in one talk. How are you going to do that in an hour? Have you written this talk yet?
So a couple of things. That is the theme of my next book. So it's kind of a book talk. It's really kind of a book talk. The title of my next book is Starry Messenger: Cosmic Perspectives on Civilization. And it comes out in September, and it's like a month before the conference. And I was invited to the conference. And so here's the origin story of why I'm even doing this at the conference. Generally, I don't attend skeptics conferences. I'm scarce at them. You all do boat rides and go on fun trips, and there's all this stuff that happens. I generally don't attend for the following reason. I'm a huge supporter of the skeptics movement. Huge. I support it more than any other thing that's going on out there. So I am there in financial spirit. Okay. But skepticism as a thing unto itself is not what I do. And there's a whole spate of other people where it is what they do. It is what they do. They write books on skepticism. They write books on debunking false claims. And so I don't need to be in the middle of that, because I'm not a professional contributor to that field, and dozens of other people are. And so I keep my distance to make sure that the attention is allocated to whom it belongs and how and when it needs to be delivered. The difference now is this next book for me is not just about astrophysics. It gets in there, and it's my life's wisdom on what I think when I hear people say things about their religion, about their politics, about their belief systems, about anything. And I say, they have not benefited from this other point of view. By the way, it's not a point of view that's opposite theirs, not always. It's a point of view that they don't even see a vector towards it. It's a cosmic point of view. It's what your ideas look like from above, not just stratospherically, but from space, from the moon. You're here warring over a line in the sand, and from space, there are no lines in the sand. There's just ocean and land and clouds. And I occasionally introduce what an alien might think coming upon Earth, viewing human behavior. And the aliens said, "You're doing what?" oh, we're having a war across this line in the sand. Aren't you all the same species? Yeah. Doesn't the land all connect and you all live on the land? Yeah. Isn't Earth this tiny little speck in a yeah. And you're killing each other over what? Oh, well, these people worship a different god from these other people, and these people have a different skin color from these other people, and these people have, and the alien would just leave immediately, run home, and say there's no sign of intelligent life on Earth. Because think, an alien would be so different from us, at least as different as any other life form on Earth is from us. We all share common DNA. So an alien from another planet is going to look really different from us. So different that everything we identify that divides us would go unnoticed by them. In the same way, when you look at goldfish, are you saying, oh, this goldfish has a slight little extra fluffy, fluttery thing on its left side compared, are you thinking this? No. Are you thinking these are the male ones and these are the female ones? You have no idea. Plus, you don't even care. Most animals out there, you do not know, unless they're birds, you do not know if they're male or female. Unless you're an expert, okay? And you think you've seen one, that you've seen them all. So that's how lazy we are in categorizing and thinking about the differences within the same species of other animals. I don't see why an alien wouldn't think any different from us. You got 4 limbs and a head and you walk, there you go. And you walk upright, you're human. We got this. Well, this person has a different hair color. Hair is what? You really paying attention to that? You really care about that? Care enough to kill them? To kill each other over that? The book is filled with examples such as that. And in this talk, I'm going to handpick examples that best fit the skeptic's portfolio, which I presume would maximize interest in what I say.
Fantastic. And one of the things I often say when people ask why, why is there a skeptic movement at all? Isn't there science? And I've actually pointed out my perspective on it is that science pushes the envelope of our understanding, and skeptics kind of hold the line because science has moved on. There are no ghosts or whatever, and but people still think there are, and they what science says is misrepresented. So the skeptical world reminds people, no, we've already shown there's no evidence for this.
Yeah, I like that, because the scientist on the frontier doesn't have the time.
Yeah,
they might have the interest, but they don't have the time or the resources to chase after everybody who's in denial of science that is already settled. Right. So I agree with you entirely. You're like the backup team.
Yeah, we have your back to science. Yeah, cool. So I also saw you're on the conference schedule. You're going to be at a VIP luncheon on Friday, and then you're going to receive the Richard Dawkins Award on Friday evening. That's scheduled for an hour. So I presume there's going to be more to that session than him just handing you an award. Do you have?
Oh yeah, we're going to sit down and have a conversation. We all love Richard Dawkins. Most of us love Richard Dawkins. He's I deeply respect his science, the facility with which he puts together words into sentences that communicate succinctly and interestingly ideas that he has.
Plus his accent makes it just sound so much more intelligent.
As captured in his books. And I remembered reading his books, and I said to myself, if I'm ever a communicator and I write books, I want to be half this good, and I'll be completely happy. So to receive an award in his name handed to me by him, I consider that one of my highest honors in life.
So, so you're scheduled to be there Thursday and Friday at least. That means you're going to be in Vegas for quite a while. Will you be attending the other sessions, or do you have other things that on your schedule to do? Like
I haven't. I'm not close enough to those dates yet.
Okay.
To really figure it out. I'll still be in the feeding frenzy of the release of the book, and so for all I know, I'll be in my hotel room running interviews all day.
Oh, I didn't notice. Sometimes they have book signings for new books out. So yeah, that's interesting.
That's what I'm saying. So I can't know this early, but I can guarantee that I'll be there for those 2 events. By the way, in the book I have a whole chapter called Risk and Reward, where I comment on casinos and lotteries and things. So being in Vegas, I might give a little extra attention to that one.
Yeah, there was one talk a few years ago by a skeptic. Basically, is there such a thing as luck? Yeah, that was kind of interesting. All right, so
Oh, by
let's
the way,
switch. Yeah.
I think I know some of what came out in that talk, because the question was, in basketball, does the player actually have a hot hand? Okay. It hits 3 in a row and say, give it to him. He's got a hot hand. And then they're saying, no, when you analyze it statistically, it's not a hot hand. You'd expect this many in a row. But here's my rebuttal. I know you didn't bring this up, but I'm bringing it up. And here's my rebuttal to that. And I don't know if this was fully considered in it. Okay. If my shooting percentage in basketball is normally 40%, let's say, and if I take 30 shots, some number of those shots will be repeated and successful in a row. So now watch. If I happen to be having a game where, for whatever reasons, where I'm shooting 50% or 60%, then I actually do have a hot hand in that game. I do have a hot hand. Okay. You can analyze it after and say, okay, he was 60% shooter for this game. And so the number of successful shots in a row is commensurate with being a 60% shooter. But if I'm normally a 40% shooter, in that game, I had a hot hand. And that needs to be respected. And I don't think it is in that kind of analysis.
I'll have to,
Denying players the chance to excel above their average.
now you want me to go back. I know they recorded that and it's up on their website somewhere. I'll have to go back and watch that and see what they said about that. All right, let's go to science communication. Can you give me your thoughts on the importance of science communication, especially in today's world?
Well, the two sides of that. One of them is what science is being discovered, and is it cool? Is it fun? Does it matter to you? Should it matter to you? So there's communication of just the moving frontier of discovery. And I think all scientists share that obligation. Not everyone is equally good at it. So maybe you would distribute it according to ability or interest, sure. But I think we all have that obligation. Then there's the misinformation in the world that would and should yield to scientific analysis, scientific explication. And I think that's the more pernicious part of your question. Why do people still walk among us who think Earth is flat? How is it the 21st century and there are people, fully grown human beings who went to college, who fear the number 13? Like, what's going on there? And for me, is that really science education, or is it a gap in our kindergarten through 12 schooling where we never learned what science is and how and why it works? Science was always presented as a satchel of knowledge in a textbook with the vocabulary words in boldface so that you can memorize them for the test. That's what science was to so many of us, myself included. I mean, I knew better at the time, but I said, really, this is not getting me closer to the machinery of what science actually is. I think a consequence of it, a cost of that, is people just think of science as any other subject that can just change whatever. If they don't want to believe it, they don't have to believe it. They think their belief is as important as experimentally verified conclusions. And
more important.
To come out of school thinking that way means you are deeply disconnected from how the modern world works. This is not medieval days where there was no science and belief systems ran everything. No, you don't have that luxury. And I've said before, the good thing about science is that it's true whether or not you believe in it. And what I mean by that, and I say it in the book on Truth and Beauty in that chapter, that science is exquisitely tuned to establish what is objectively true in the world. That's its point. That's its purpose. Once that is established, it's not later found to be false. And to be established is you have an idea, and I don't believe it. I don't trust you. I don't even like you. So I want to show that you're wrong. And then I do an experiment. I get the same result as you do. And someone else does it. And we all start getting the same answers. And you say, you know, we have a new phenomenon here. This is a new way we understand how the universe works. That goes in the books. And we all move on. That does not later get undone. It can get expanded upon. You can find out it's a smaller part of a bigger truth, but that truth is secure once it's been through those tests. And that's the kind of truth I'm referring to. You can't wish away E equals MC squared. You can't say, I want to protest the laws of gravity because I gained 3 pounds this week. That does not work. But you can protest other laws because they're unjust or whatever. All right. And so I blame the school system, which is an easy target, unfortunately. But if we were talking about educational reform, I would teach science completely differently from how it currently is.
Yeah, that was a specific question from another Facebook follow-up. Melanie Tressa King asked, how can we improve science education? So basically to stop teaching just facts and maybe methodology.
No, not methods. Methods is too mechanical. No. I mean, yes, methods, but that's not it. The it is what does science do to establish what is true? Is it the philosophy of science, perhaps? But philosophy of science classes tend to go overreach, I think, into philosophy in ways that are not helpful to the practicing scientist or to the person learning. But I think it's drawn from the philosophy of science. It's what do you do and what are you thinking as you're doing this experiment? I'll give an example. This would have been a fun example had I gotten this. William Herschel discovered the planet Uranus. No one had ever discovered a planet before. They're bright enough in the night sky. They were known to the ancients. They were known to cavemen. Okay? So this is a new object in the sky. He sees an object moving from one night to the next. All right, you can't take a movie, not then. He takes an image of the sky, and then a few days later takes another image, and one of the objects is in a different place. It has moved. And you read the discovery paper, and here's what he says. He said, I've discovered a new comet, but it's a strange comet because it doesn't show any fuzz on it, which would be typical of a comet. I'll keep monitoring it. Okay, so he keeps monitoring it. It still doesn't show. So people had discovered comets before. No one had discovered a planet before. So these are steps slowly taken, and he has a bias. But the bias is it's probably a comet. But he's curious enough to continue to ask questions. If it is a comet, it's a different kind of comet. Okay. And then he finally gives up and said, I think I've discovered another planet. And then what do you name it? All the planets are named after Roman gods. No one had ever discovered a planet before to name it. So he named it after the king, trying to get in good with the king, all right? King George. So for about 30 years.
Oh, I had never heard this.
Yeah. For about 30 years, there was Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George for the planets in the solar system. Yeah. So, but anyhow, so the fits and starts that occur when you're a scientist, it's not just some eureka moment. It's not how that works. And I'll give another example. And wouldn't we delight in having learned these examples in school? All right. It was not Herschel. Was it Herschel? Yes, William Herschel again. Okay, same dude. He sees the spectrum that Newton talks about. The red, orange, yellow, green, blue, violet. Newton first showed that white light is composed of those colors. He passed white light through a prism. The colors come out. It's easy to say, oh, well, the prism made those colors. It's not in the sunlight. The prism has something that's putting the colors there. Then he took those colors, went back through the prism, and out the other side came white light. Prism is, the white light is entirely to blame for this. The prism is just revealing it to you. All right. So Herschel had the question, I wonder if the different colors of light have different temperatures. Just to even ask that question, you got to be deeply curious. So he lays down a spectrum on the table from sunlight coming through a slit in the wall and through the curtain. And he has at least 2 thermometers. So one of them is the control thermometer. He puts that to the side of the spectrum, on the other side of the red. Okay, there's nothing there. All right. And then there's red, orange, yellow, green, blue, violet. He took his second thermometer and put it in each one of these colors and wrote down the temperature and compared it with the control thermometer. And what did he find? The control thermometer registered a higher temperature than every other color of the spectrum. And he said, oh my gosh. Well, I don't know if he said OMG, but he said, could there be a form of light, quote, unfit for vision, that is showing up to the left of the red on this spectrum? Light unfit for its vision. He proposes this because he put that thermometer somewhere else and it didn't register. It was like right next to the red, where nothing should have happened because he didn't see anything. This was the discovery paper for infrared light.
That was totally fortuitous. I mean, he could have
Yes.
put that thermometer farther away and wouldn't have gotten that.
That's well, because he's a good scientist. I mean, yes, it was fortuitous, but luck favors the well-prepared. He chose to not put the thermometer in the kitchen. He laid it right next to the other colors. I think most of us would do that, I think. But my point is, that's fascinating. He made a discovery, and he didn't quite understand it at first. This is how that goes. Everything a scientist does is not known and understood the moment it's discovered. No. So let's look at the head scratching that goes on as we figure this out. And I think the scientific efforts, the scientific world, what's the word I'm looking for there? The scientific procedures would gain much higher respect, I think, if people can see what these investigators are doing as they have these thoughts and as they perform the experiments. If we saw that, then when a scientist says something and we say these 10 other scientists have papers that agree with it, you'll say, I'm all in. Let's move on to the next problem.
So the series that you were a big part of, Cosmos, did very good at that. They do these historic vignettes and showed discoveries from scientists. So I actually wanted to ask you a little bit about Cosmos. I actually interviewed Andrian in 2020 in my column upon the release of Possible Worlds. And, we talked all about that series. Tell me about what you loved most about doing it.
Well, it's I bet you that anyone who thinks Cosmos, the TV series, they will not at the same time think the word documentary, even though it is. Okay. It's a different way of presenting knowledge, wisdom, and enlightenment, so that you not have to sit on the couch and take your medicine. And no, it's give me more of this. And at no time are you think, here's a lesson plan. Okay, we could be tested on it later. It's a different way of approaching. And this was pioneered in the original series, the 1980 series, with Carl Sagan. And Andrian, by the way, is the secret sauce of all 3 series. She's co-author of all 3. Everyone remembers Carl because he was the big name, but part the curtains, there's Andrian.
Yeah, I tried to make that clear in my article that she's the creative force behind it, really.
Correct. And so the idea that you would present science not as an academic subject, which it clearly is, but as a passion for discovery. You present science as something where your emotions matter, not only in the doing of the science, but in how the science can affect your knowledge and awareness of who and what you are relative to other people, relative to nature, relative to planet Earth, relative to the universe. And this is a thread that runs through practically every scene of all 3 episodes of Cosmos. So I think that's its gift to the world. This profound difference that distinguishes it from all other documentaries. And like I said, Anne is the secret sauce there.
Absolutely. So when I talked to Anne about this over 2 years ago at this point, I asked her if there's a 4th season in mind. She says, yes, I have stories in my head. Some of them are on paper. I know what's going to happen. I want to take a break. But now that it's been that long, do you know anything about another season in the works?
What do you mean that long? You mean 2 years? That long? It was 34 years from 1980 to 2014, and then 6 years to the next one. So, my gosh, such ungrateful people.
That we're just used to having stuff released.
You just want seasons layered after layered after layered. And
so, sir, is anything in the works? Do you know?
So it's all up to her. She owns the franchise, if we can use that term in this context.
Yeah.
We had talked about passing the torch. You know, I'm 60. I'm older now than Carl Sagan was when he died. Okay. If I did my math right, about the same age. So I don't have any hesitation handing a torch to someone else. Cosmos is an idea. Cosmos is a way of delivering knowledge and enlightenment to the public. And so let it live on forever. And it needn't live on with me. In fact, I will know I have succeeded in life the day I can walk backwards out the back door, okay, and escape to the Bahamas. And inside that room are dozens of other people who are presenting science to the public in ways that are life-changing to those who pay attention. And you won't even notice that I'm missing. That's my goal. I don't even so because if it's just me, by the way, it isn't just me. There are many people on that landscape, but I'm just speaking more in the end state of it all. That there's countless numbers of other people, and nobody has to turn to me for that message. Because the extent that you do and will continue to go forward, that's like cult building. I don't need that. I don't want that. I'm an educator. I don't want to be the object of your interest. The science needs to be the object of your interest. And get people who are good at that, who want to do it. And Instagram and Facebook and TikTok are right now filled with such people. Okay. There's Physics Girl and Astro Girl, yes. and
I follow a lot of them.
Just go down the list, and they're posting more interesting stuff than I am. Okay, they're tracking the flow of discoveries out there. We've got Phil Plait, who we all know and love from the skeptics world.
Astronomer.
He's closer to my age, but I'm just saying, plenty of other people are out there, and so I value the growth of that community, and so if there's a next Cosmos, let it be drawn from that community. I have no hesitation about that. And that's up to Anne.
Thank you. So let's see. Let's talk about Mars, some planetary astronomy. 6 years ago or so, you did a promo for the 2015 movie The Martian, based on Andy Weir's novel, which is set in 2035. It was cleverly presented as if you were discussing the upcoming Ares 3 mission, which was the plot of the movie, on a StarTalk episode from 4 years after the first Martian landing, which in that reality in the movie was set at 2029. So considering the state of technology and all the other hurdles to sending humans there, what do you think is actually an achievable date to putting people on Mars?
2050.
2050. 2050.
Yeah, because it's not about technology. We landed several SUV-sized rovers on Mars.
I don't think people know how big those things are.
No, they're huge. And it's not about getting to Mars. Yeah, there'll be some new engineering challenges, but engineers love that stuff. Okay. So, how about the radiation? Let the engineers figure it out. They'll love they'll come up with some clever solution. They didn't have to before because they weren't paid to, but now they're going to get paid to protect me from the radiation. They'll do it. I have no hesitation about it. So to say Mars is far away is not the same thing spoken today as in the early 60s saying, the moon, we'll never get to the moon. The people who said that didn't think we could ever accomplish it technologically. And they were all shown to be wrong, of course. And then when we accomplished it technologically, people said, oh, we'll be on Mars by 1985. Where they got it wrong was we didn't go to the moon because we just felt like going to the moon because it was in our DNA. We went to the moon because we were scared witless because the godless communists had beat us into space, and they could fly over our heads, not in our airspace, but in our space. And there's no treaty controlling that. And if you can send Sputnik, which was a peaceful radio transmitter, however, it was embedded in a hollowed out intercontinental ballistic missile shell. Oh my gosh, yes, we lost our shit. All right. And so, yeah, we went to the moon, driven by geopolitical forces that had nothing to do with our DNA as humans or our legacy as Americans, as discoverers. That is not what got us there. And then once we beat the Russians and they had nothing planned, we're done. We're not going to Mars because you're not motivated to go to Mars. There's no reason to do it that could justify the $1 trillion it would take to make it happen. That's why we didn't land on Mars by 1985. And you're saying we'll get there by 2029. I would ask you, what would be driving it with humans? What? All right. You have $500 billion. Where are you going to get it from? Is there a return on that investment? No, not really. No. Elon Musk's meeting with venture capitalists. I want to go to Mars. How much? $500 billion, maybe $1 trillion. Is it dangerous? Yes. People will probably die. Any return on the investment? No. That's a 5-minute meeting. And Elon does not go to Mars. What do I think will happen between now and 2050? There might be a geopolitical force operating on us. China decides to put military bases on Mars. And by the way, Mars is already red, so that'd be an easy sell. That's an easy sell culturally. So then we freak out the way we did in 1957 on October 5th and the day after Sputnik. And we say, okay, we're going to put humans on Mars. Oh, but we don't have a spaceship to do that. Elon does. So he rolls out. So yeah, we might be on one of Elon's spacecraft. But if we do, based on my read of history, it'll be paid by taxpayers, not because he has a business model that'll make this something that'll pay for itself.
Have you seen the Apple series, Apple TV for All Mankind?
No, I have not. I started it, and it's what's the word? It was
alternative history.
Yeah, it's an alternative history, which I'm intrigued by just in principle.
Oh my God, it's fascinating.
I didn't have the time to binge it.
So
during COVID, I birthed the book. So I said I can binge Rick and Morty or I can write a book. So I wrote the book. So I'm very behind on my binging. I want to see The Expanse. That's I'm curious of what you're going to think of the science, but from my perspective, that being educated as a mechanical engineer, and I designed spacecraft for the first 16 years of my working career, I found it the most correct science I've ever seen in a science fiction show. Excellent. But so for All Mankind, for people who don't know, is an alternative history where the Soviet Union lands on the moon. Just contrafactual. That's what it is.
What's that?
Contrafactual.
I
think that's the.
Yeah, I heard that. I haven't heard that term.
I think that's the term. It's you take some facts and you switch it up, and then you run history.
Okay. So in this case, the Soviet Union's N-1 rocket does not blow up in the launch pad. They make it to the moon the same month we do, a few weeks earlier. And then the space race doesn't end because of that. And all history, in fact, changes. Who's elected president is different. Women's rights are accelerated because they become astronauts because the Soviet Union does it. And in the third season, we're going to Mars in 1990 something. Yeah, it's amazing.
Yeah, so that would have been geopolitical forces.
Exactly.
Just as I'm describing. Correct.
Yeah.
Correct. And it's not a matter of, is the technology ready? They'll make it ready. That's not a problem.
Yeah, I find it fascinating for that reason, because I think this possibly could have been, and like some things are worse in the world and some things are better because of it. For
Mhm.
one thing, the Soviet Union doesn't fall.
By the way, there's another, what was it? There's an episode of Family Guy where Stewie's time machine goes haywire and they land in these random places. And one of them is a very modern place. You know, they're flying cars. Sorry, it's sirens in Manhattan
I
here.
remember that.
Yeah. So there's flying cars and everything's modern. And Brian asked Stewie, is this the future? He says, oh no, this is the world in the year 1800. Said, well, how's that? Oh, in this universe, Christianity never never happened. Okay. So I thought that was an interesting sort of dig on what regressive forces have existed historically against the progress of science. Of course, there are the apologetics who have written that Christianity and
Accelerated
religious
science.
institutions enabled science. And I think the real answer there is the Christian institutions were the only institutions. So, and they were the only universities, right? So if there was ever going to be anything to happen anywhere, it would have to be in such a place. And so if you want to now take credit for birthing science, okay, but you can imagine having it birth even faster without it, if you could. But that's what you're dealt with at the time.
Yeah, absolutely. So what are your other favorite science fiction TV series and or movies that you have had time to watch?
Oh yeah, I like a good science fiction film. I'm getting a little fatigued with superhero movies. I think there's more to storytelling than a superhero. When they were the occasional movie that would show up on the landscape, as well, let's all go to see it. But now there's like 5 a year or something. I don't know. I've lost count. And plus the
3 this year.
3, yeah. And is Star Wars? How many can you really put out there?
They've cut back on that because they didn't do so well in the last few.
Yeah,
they've gone to the TV.
Yeah, but cut back. I mean, we've lost count. And of course, the Star Trek series, it was, had many movies. And so I don't know what to make of it. I'm ready for other kinds of film and other kinds of storytelling. But I'd like a big, expensive, entertaining picture, action picture, sci-fi picture. I do embrace them.
I recently watched a quirky time travel film, and that's one of my favorite genres, called Future 38. Beyond surprised to see
that doesn't get quirkier than Future 38. Okay. No. Very low budget indie film. What are you doing watching movies like that?
So people watching this, Neil did the introduction sitting in a movie theater with a big vat of popcorn, and his quote was, "Finally a movie that gets time travel right." That was hysterical. Clearly poking fun at your Twitter situation of commenting on the bad science in films. How did that come about?
Yeah, so Future 38 is a it's a time travel story that takes place in 1938, and it's imagining a world in the year 2015 or whatever the release date was of the actual film. And they claim to have discovered it in a film vault. All right. And so that's the ruse that you have to buy into. And so I introduced the film out of this film vault. All right. I'm a modern person in the year 2015. And what makes the film fascinating is it takes the technology of 1938 and extrapolates it forward to the year 2015. And
what they would have thought 2050 was going to look like from
correct, based on extrapolated from 2038. Right. And one of my favorite extrapolations is so there's a flat panel monitor on the wall, okay, and there's just a woman just sitting there, looking around, minding her own business. And you say, oh, they've got a TV there. And it's like, no, it's not a TV. Okay. You walk up to it and you pick up a telephone, and that's the operator. You're talking face to face with the operator to connect you to the phone line. Right. And not only that, they have these like cell phone looking things, all right? And the cell phone rings, and it has like a modern cell phone ring. and they pick up their cell phone and they plug in a thing, and it's one of those phone
It's a big cord.
that they're using. It was just brilliantly future retro, and they really thought about the limitations of future thinking in this. And it takes place in 1938. There's a World War II Nazi nuclear power thread through it. It's basically a I don't want to call it a screwball comedy because that would devalue it. It's a well thought out comedic treatment of time travel in that context. And I was asked if I would just introduce it to give a little sort of scientific authenticity to it. And
I assume they sent you the script. So
yeah, and I commented on it, and no, some had already been filmed. They sent me the script for my own, what I was going to read, and I made some adjustments, nothing serious. It was a very well thought out concept. Plus I knew it was an indie thing, and so he said, how much should we pay you for this? And I said, I don't, just pay my car service to the studio and back, and give me a year's supply of popcorn. That's what I wanted. So I got this flat of Orville Redenbacher popcorn, and I'm only just now finishing out. And I kept that bucket. It's this huge, biggest bucket I've ever seen.
Wow, does popcorn last that long?
No. I mean, unpopped popcorn, hermetically sealed.
Ah,
It lasts forever. Yeah. So the bucket just has popcorn on it, and I'm munching on the popcorn while I'm delivering these lines. Yeah, so if you can find it, it's a charming film and not too long, and it's very clever.
it's amazingly clever. So I'm wondering if you saw this one goof that I caught. There's a scene towards the end. They're driving down a Manhattan main thoroughfare, and the scene is looking at the people in the car from the front, looking at the back, and you can see one Freedom Tower there. So it's the reconstructed World Trade Center is in it. It's like, oh, they missed. Why did they do that?
No, I mean, why? I mean, so what?
Well, because they couldn't have known that was going to be there in 1938. The exact building. I mean, it wasn't just a skyscraper. It was the actual skyline of New York, where previously they weren't showing the actual buildings in New York City.
Oh, I see. So you think it's slipped in?
Yes.
Okay, so that's not so in my movie critiques, I don't.
Yeah.
I let those go because they had they got it right, they would have done it right. They knew better. If all the other scenes were close edited to prevent the actual skyline. And so what I concern myself with when I give public talks on movie gaffes is when they just blundered in what they thought was true and isn't, or what they could have done better had they done the calculation right. And so another thing I don't comment on is continuity of outdoor shadows.
Oh,
because they can't control the sun and they retake things.
right.
And so I notice it, but I don't make a public.
One famous one I remember you mentioning, and then I think, tell me if I'm wrong, that when they did a re-release of the movie, they fixed it, was that the night sky over the sinking Titanic was incorrect.
Oh, correct. It was not only wrong, it was lazy, because the left side of the image was a mirror reflection of the right side of the image.
Oh.
And here's a movie who old timers will remember was advertised based on its authenticity, because Cameron went to the bottom of the ocean with Robert Ballard, the oceanographer, and they found the Titanic, and they had video of the state rooms and the china patterns and the wall sconces, and they reproduced it to exquisite detail. And that's why you're supposed to want to go see it. One of the reasons why you would go see the film. And they has the wrong night sky, which is something anyone can really check, really. And so I appealed for 10 years, and they actually finally changed it. In his centennial release in 2012, it was the IMAX.
Yeah, I went to see that.
They actually re-rotoscoped those scenes.
Of course, I didn't notice that. I didn't notice it was wrong in the first place. So did you know they had changed it, or did you watch it again and have?
I would learn from his people that they would change it, because they asked me for what sky should be there. And by the way, in reaction to this, Seth MacFarlane asked me, what is the sky over Boston, Massachusetts on Christmas Eve at 30 degrees up, looking out this window. And I said, here's the sky. And he said, I'm going to have, in a movie, I'm going to have a character make a wish on a shooting star. And this was, of course, a scene in the movie Ted. So we got to say, after Ted was released, that Ted got the sky correct and Titanic didn't. Okay. This is just, you know,
as long as the movie about the talking teddy bear got the science right. That's
the talking potty mouth teddy bear. Yes.
Yeah.
Mm-hmm.
All right. So on that note, I think we can wrap it up today. Thank you again, Dr. Tyson, for your time.
Neil, please. Yeah.
It was a real pleasure talking to you. And
we've never met, I don't think. So maybe we'll
No,
meet.
we have not. I'm looking forward to maybe meeting you in real life at the CSICon conference in Vegas. That would be fantastic.
Looking forward to it.